YouTube channel.
How many people are there?
Let me see. I think now it's around. Quanto tem? Oh, okay. Okay.
Okay, no worries. Only curious. That's all.
54.
Yeah, no worries. Okay, now what I got to do now is let me check the sharing's working.
Okay.
Which is no, I can't see PowerPoint here. Let me just try that as an option.
So
that's it there. That's it there. That's it there. Got it. Okay.
So, boa noite todo mundo. Obrigado pela oportunidade. Hoje nós iremos ter uma apresentação intitulada Navegando no Futuro da Educação, impulsionado pela IA e por meio da aprendizagem cibersocial. Eu vou primeiro introduzir o professor Bill Cope, vou falar em inglês e depois eu acho que a tradução legenda em português. E primeiro o professor Cope, desculpa, vai apresentar e a gente vai abrir uma sessão de perguntas e respostas. Sinta-se à vontade em escrever em português, espanhol ou inglês. Eu e o Vitor estaremos aqui acompanhando as discussões no chat e a gente passa para o professor Bill. So, good evening, everyone, and welcome to our session for the sexto encontro do MELP e 4 colóquio do TECLE. Today's session is entitled Navigating the AI-Driven Future of Education Through Cyber Social Learning. I'm excited to guide you through it. My name is Eduardo. So first, I'll introduce our estimated guest, Professor Cope, who will deliver his presentation. And following that, we will open the floor for a Q&A session. Feel free to contribute in Portuguese or Spanish. We will happily pass on your questions to our speaker today. So I'm really grateful and honored to have Professor Cope with us today. It's a true privilege to introduce Professor Bill Cope. Beyond his remarkable work, he is one of the most welcoming and supportive people I've had the pleasure of knowing. He's a role model for me in both academia and life. Professor Cope has redefined education, literacy, and technology, mainly through his pioneering work on multiliteracies and AI. His research profoundly impacts how we teach and learn in the digital age and has provided invaluable tools that empower educators and students and researchers alike. So please join me and warmly welcome. So Professor Bill Cope, thank you so much for your time and for this presentation. Thank you so much.
And thank you very much for those generous words, Eduardo. It's a pleasure to be here. So I'm going to talk about this AI phenomenon. I'm going to start with an introduction. I think AI has been around for a long, long time. As early as the 1940s, Alan Turing was talking about this idea of machine intelligence. But what's happened since 2017, essentially, is a very, very significant paradigm shift. And the fact that we're using this phrase AI, it's a problematic phrase, by the way, I'm going to get to that in a moment, belies the scale of the technological change which has happened since the publication of a key article by Google Brain People in 2017 which introduced the technology of the transformer. And for those of us who work in social sciences, humanities, education, linguistics, language teaching, ironically, it's put language at the center in ways that, quite frankly, are surprising. Before that, there were natural language processing existed, but it's a very, very, in many ways, a very different kind of set of technologies. That's another whole story. But this is essentially a language technology. It's a technology which leverages the semantic patterns in language. So that makes it kind of interesting, challenging, difficult. And what I'm going to try to do in this talk is give my version of what I think that means. Let me just see, how do I move on with the arrow in this? How do I move forward in inside here? Maybe I do it down here. Sorry, I can't see how to move it now. I've just changed it to, yeah. Is that now the full screen, folks?
It is. It's working well.
Okay. Right, it's working now. Okay, well, I can't see you anymore, which is I'm sorry about. This is the funny thing about computers. All I can is see my slide. It doesn't matter. I'll talk to that. Let me just see if there's another option here where I can see. Yeah, I can see it. And let me see if I can. No, I can't. Yeah, I don't know. I kind of like. I'm not very keen about just talking to a screen. So anyhow, I can see how to toggle backwards and forwards now. So yeah, I'm not a user of Google Meet, by the way. So.
Oh, okay.
All strangenesses in these from one platform to the next. So look, there are three parts of the talk. One is the rise of platform pedagogies and general AI, generative AI. I'm going to talk about that. So these kind of things, where generative AI is going to meet us in education is in platform pedagogy. So I'm going to talk to that first. Then I'm going to talk about putting generative AI to work. So we've been building out stuff and using it now for the best part of 2 years, since not long after. Well, the big moment was at the end of 22 when the most visible versions of the OpenAI work became public. So we've been working with this since the beginning of 23. When I say working with it, I mean actually using it with our students in a platform that we've built ourselves. The third thing is I'm going to talk about the implications. What does it mean for AI and the future of learning? So, okay, I've worked out how to do this, toggle backwards and forwards. The first thing is the idea that kind of what's behind this, the platform pedagogy stuff, and the mechanization, if you like, of pedagogy is not new. This is B.F. Skinner's teaching machine from 1954. Now, this was a purely mechanical machine before computing, but it was kind of it's been a fantasy all along to have machines do the teaching. And this is B.F. Skinner, the great behaviorist psychologist. He created this thing in a complicated way, which was kind of quite, in some ways, quite visionary. Then the first computer-based thing, I'm a historian by training, so I'm always wanting to know the origins of these things. And the origins is always kind of instructive about what we're experiencing today. So here at the University of Illinois, they began the project in 1959 of creating the world's first computer-mediated learning system. And we've actually written an article about it if people are interested in it. And it's not because it's a strange, obscure thing to be interested in. It actually is incredibly instructive because almost everything that we face today, they faced almost immediately by about 1960. All the specific pedagogical issues, human issues, epistemological issues, technical issues around computer-mediated learning, they were addressing very early on. And one of the instructive things is that a lot of foundational technological things were invented ancillary to this machine. So the first plasma screen, and the computers didn't, to that point, didn't need a visual interface. But if you're going to do learning, you needed a visual interface. So they created the plasma screen. There was also the first time language had been carried through the machine as well, because before that they were punch cards and they were purely calculating machines. If you're going to deal with humans, you've got to, or non-computer science humans, you're going to have to build this kind of an interface. So it's actually a really instructive story. And what came out of this was the very first emojis, the first people talking to each other in the manner we do in social media, talking to each other, students talking to each other through this environment. The first sort of schematic learning management system as well, all by the early 1960s, 60 years ago. So it's kind of very, very instructive, and it's a really great history. But the platform part of it was these were terminals. You can see the terminal there that were connected to a mainframe, right? So in other words, crucially there was a platform at the center of it, and the kind of temporary diversion into PCs was only that. And in fact, this basic kind of cloud center and periphery hub and spoke architecture was there right from the right at the start. Now, moving on, we're racing a long way forward now. What I want to talk about is the peculiarity of these technologies now. Now, essentially, what's underneath it is no different from what was underneath Plato, which is, we're on terminals of sorts and we're connected back to a platform. In this case, it's a platform which has a large language model, and we interact with the large language model through a chatbot. So there are kind of two key technologies which come together here. The chatbot and the large language model. And what we have is in that space uniquely reconstituted digital artifacts. Essentially, it's a text-based technology, but secondarily, it can do images, sound, and all sorts of multimodal combinations as well. But essentially, it's text-based. So that's kind of what the technology is. Now, what I want to say is that this isn't new either. So, in fact, Joseph Weisbaum here was the first person to construct one of these chatbots. He was at MIT, 1966, a long time ago, nearly 60 years ago. And he built this chatbot called Eliza. And what was very interesting, and he had kind of insights, which are also the case with the dialogical nature of generative AI now, which is build a dialogue and find out about the user. Because by finding out about the user, you're going to give the user things which are relevant to the user. It's a history that's really, really worth reading. He became, as early as the late 60s, he became freaked out about this technology and wrote a very serious critique of where these technologies might be going. So it's worth tracking back the history. So that's the chatbot side of things. The LLM side of things also, in some senses, is not new. And this is here an image of someone who you won't know, probably, but you might know, a tremendously important person in some very problematic ways. So he got his PhD here at the University of Illinois in 70s. And he was somebody who created what was called statistical language processing. So he said, look, it's very hard to know what the structure of language is because it's so damn complicated. Chomsky got himself into knots for his whole career trying to work out what the inner structure of language is. It's so incredibly variable and so unfathomably complex and so rough around the edges and everything about it. So initial attempts to deal with language in computers essentially failed, and they essentially gave up. And they were ones based on structural analyses of language. So what this man, Robert Mercer, did, a key article there, or one of the key, the article there's a reference to a reflection of his, is he said, look, all we can know is about statistical probabilities, that this word goes with that. We've got a bag of words out there, and we can analyze statistical patterns in the infinite complexity of language, and then we can see repetitions in those patterns. Now, a little footnote to this story is that he got his degree at the University of Illinois, went to work for IBM, and then decided that he'd put his skills to good use in becoming a billionaire and set up a private equity firm or whatever it was that combed stock market information with using these methods, and he became fantastically wealthy. But then later in his career, he put his wealth to founding Cambridge Analytica. So he was Donald Trump's main financial supporter in the 2016 election. And Cambridge Analytica then used these techniques to come through Facebook and build out a winning electoral strategy for Trump in 2016, way ahead of the Democrats at that particular time in terms of these technologies. So it's a kind of, look, these are kind of salutary stories, by the way, but they're also, these are the founding moments of this stuff, which is not new. I mean, this is stuff that's been around for a long time. Now, having said that, what's interesting is I also said to you that generative AI is a paradigm shift. So underlying it, it's still statistical language processing. Underlying it, it's still chatbots. But there is the capacity of these GPTs to deal with language is phenomenal. So in other words, what we're having is everywhere, students and teachers and everything, you know, get the machine to do your work because it'll do it better than you can. You know, give it the, you know, you got to write your essay on the history of the causes of the French Revolution or some darn thing, and it'll write the essay for you. So this is a big problem for education. The minute you've got a machine that can do cognitive work, you've got a machine with which to cheat, so to use that colloquial word. So this is kind of set a panic amongst people, but don't panic because we've got a solution. What's the solution? You ready for it? Next slide's the solution. The solution is lock up your students, put them all in a room like this, deny them computers, give them a pen and paper, don't let them talk to each other, and then this becomes actually the classical modern, highly individualistic form of education. There's an educational paradigm under this. And you know what what's the definition of learning? The definition of learning is long-term memory. That's what it is. It's whatever you can remember without support. Now, who does intellectual work without support? Books, references, citations, you know, who goes shopping without a list? You know, I mean, you know, this is a crazy thing which is on about reducing learning to what you can remember. And what's the definition of long-term memory in this model? The definition of long-term memory is what you can remember until the day after the exam, right? Because, you know, you were only measuring what you can remember up until then, not what you remember beyond then. So, you know, this is the only solution to AI. Well, no, it's not the only solution. We have to come up with new solutions. And by the end of the talk, I'll suggest what some of the solutions are. But before that, what I want to do is I want to talk to you about some of the intrinsic problems in generative AI. And what's interesting is that they've put a huge amount of work into fine-tuning things, and these problems are less problems now. But they were problems. This particular text I've got here was from GPT, which one? Might have been 3.5, which was the fanciest version at the time when I did this. But the reason why I left it is because underlying the technology are still these intrinsic problems. All you can do is you can mitigate the problems, but they're still there underneath. You can, you know, gradually make it better and better and better, but the problems are still there. So I, in an unhealthy sort of way, know more information than a normal human being should be about the Peloponnesian Railway. I'm going to give you that as an example. Right, so the Peloponnese is in Greece, and what there was is a medium gauge railway, then a narrow gauge railway that ran from Athens all the way around the Peloponnese, past all these ancient Olympia and past all these fabulous places, past Corinth and back to, so it went around the Peloponnese and back to Athens. People might know Mary is from Greece, and we have a house right by where the Peloponnesian Railway ran, and we go there regularly back to the house where she was born, in fact. So I'm interested in this railway. It's really quite a beautiful ruin now. And you can see here, these are some photos I took on the left. That's the Corinth Canal, and you can see the bridge, the railway bridge crossing the canal, and you can see places where the ruined railway is. So I told GPT, I said, write an essay on the history of the Peloponnesian Railway with references. Okay, so here it is. It looks pretty damn good, to be quite frank, doesn't it? I mean, if you gave your students the job of writing an essay like this and they come up with something like this, you'd be probably quite pleased. Anyhow, when we go to the next slide, we start seeing some problems. Firstly, it speaks in this very kind of 5-paragraph essay kind of way. So it's been taught to speak in these particular kinds of ways, and it has a tone, it has a way of speaking, all of which has been trained to by humans, to be quite frank. It doesn't do it automatically. Humans have been training it. So, however, on the second last paragraph and then the conclusion at the end. But the thing I wanted to tell you is, firstly, decommissioned in the 1970s. No, it was closed in 2011. So that's pretty darn wrong by a big margin, right? So this is called hallucination. I think a better category for it is bullshitting, telling lies, making stuff up. To use these kinds of anthropomorphic metaphors is a bit deceptive. It assumes that it's really intelligent. It's not. It just puts the premium is on building coherent text, and it cannot have any notion of fact. And secondly, the references down there are just simple. They look pretty darn impressive. They don't exist. Sorry. I've got to look. Can I just? I'm gonna just one moment. That's a kind of
Sure.
I'll stop for one.
Just a few. Só um minutinho, pessoal. Enquanto isso, se vocês quiserem já ir pensando algumas perguntas, eu e o Vitor, a gente está aqui, a gente vai acompanhando o chat. Se vocês quiserem já pensando em algumas questões, a gente vai organizando aqui também. O professor Cope, ele estava falando começou a palestra apresentando um ethos, né, uma organização, um jeito de pensar que acabou fundando talvez um pouco o ChatGPT e a IA de forma geral, que é muito antigo. Ele trouxe 2 modelos, né, que vão fundar esse ethos. Um é pela própria concepção de chat, né, o que é chat. Ele trouxe o exemplo da Elisa, que é um chat, uma ferramenta que foi criada para simular a interação entre usuário, entre um psicólogo ou psicanalista e um paciente, e também um modelo de análise linguística, de linguagem natural, que baseado em estatística, que acaba essas duas formas de pensar a língua e a interação, acabam meio que fundando uma mentalidade que vai dar origem aos modelos de linguagem que a gente conhece hoje, os grandes modelos de linguagem, né, como o ChatGPT. E é isso, esperar um pouco. Só o professor Cope teve um problema, a gente vai logo retornar. Hi.
Very sorry about that, folks.
No, that's okay. It's okay.
I
Those
actually,
things happen.
I thought this was going to be 2 hours earlier, and I had a class now, and I had an online class. I had someone else take the class, but they just messaged me to say that they weren't, that I was the host still, so I had to make them the host. So I'm very sorry, folks. These are the hazards of technology.
Yeah, those things happen. Don't worry.
Yeah. So my apologies for that, folks. I'm back again. So let me go back and let me let me go back and share my screen. So that I will there. So let me go back here and okay. Okay, there we are again. Can everyone see that okay, folks?
Yeah, perfectly.
Okay, so the references are made up. They look pretty darn impressive, and even was there a URL there? There was a URL further down, which is obscured, doesn't exist. They just make the whole thing up. And actually, one of the important points about this is that when the LLM has used all the text of the world, but has lost track of anything about where those texts came from, it's become just a bag of words with vectors relating those words to each other. And there are no, it can reconstruct those words, but it's lost any understanding of where those words come from. Now, that's still the case, by the way, and it's going to be always the case with this technology, even though they refine it in all sorts of ways. For example, now to eliminate these things called hallucinations, they tell the thing to be more unsure, not certain about, don't be so definitive about things. So there are all sorts of ways in which they're kind of fine-tuning them at the moment. So this is important. And one of the things is that underneath, these are some deep kind of structural problems with these things. We've seen the sourcing problem, we've seen the facts problem, but also it doesn't have any idea of a theoretical frame in there as well. It's just words that happen to be associated with each other. It's basically, look, crudely, it's a next word predictor. It predicts what word follows the previous word. Ethics, if it's well mannered, it's not because it's sources of that. So it's used a whole pile of stuff where people are racist and sexist and offensive and hate each other and abusive. That's the nature of the text of the world. It's a mixture of things, and all the bad stuff's been filtered out by people who are looking after your morals and mine. Now, that's not necessarily a good thing, but that's just the reality of it. And it has a kind of it's California liberal, actually. That's what it is. It's made in California, essentially, and it's liberal. And the last thing is that it's tuned to be friendly to you and to be nice to you, and it won't be critical of you. And it's because it's been skewed by humans to be that way. So if you want to give critical feedback to students, you've got to really force it to do that, because it doesn't do it naturally. So these are kind of intrinsic issues and intrinsic problems that we need to kind of be aware of. Now, but having said that, this is a very big moment in my sense, in my view. So, 1039 was a big moment, 1450 was a big moment. 1450 was the invention of the letterpress, which was typography, modern typography. In fact, it had been invented in China in 1039, but didn't become widely used by someone called P. Sheng. But what became big was the mechanical reproduction of text. Before those two moments, or before this moment of the text had to be retranscribed, this was the moment when text could be reproduced, which has enormous significance, as everyone knows quite well. But this is another huge moment, which is the mechanical production of text, right? Which is, for a machine to produce meaningful text, which is a coherent meaning of kinds that have not been made before. Generative AI is the first machine to do this. But the most important thing is they're operating off the infinite combinatorial possibilities of language. Human beings do that in the sense that the last 300 words I said have never been said before in quite that way, in quite that order. And your last 300 words as well have never been said like that. So what we have is we have a system of infinite combinatoriality or something, you know, combinations. But this is the first time a machine has been able to take the infinite combinatoriability of language and make meaningful text out of it. So this is actually a very big movement there. This was I created this icon using DALL-E, so which is one of the image generators. So anyhow, this is what both generative AI and humans can do. They can both make coherent meaning from the endless combinatorial possibilities of language. But they have fundamentally different mechanisms for taming entities. So let me go on and talk about that a bit. So generative AI it's a text technology, we've said that. And let's talk about what text is first. So text is that which can be expressed in Unicode, which includes math and code. So Unicode is now 150,000 characters or so, which includes a handful of phonemes only, but a lot of ideographs, which is down there, Chinese, numbers, symbols, emojis, all that kind of stuff. So Unicode is a single text system for cataloging all the graphemes that are used in character sets. And if you're talking between Facebook and a message system and whatever, the emojis, the face of the happy emoji might look slightly different, but the underlying semantic is identical by virtue of the standardization that happens in Unicode. So really all generative AI can deal with is text defined in this way, is graphemes, Unicode graphemes. And what it then does, it actually doesn't deal with the graphemes themselves, it deals with tokens. So, and I'm facetiously saying we're all Chinese now, because there's no meaningful unit beneath the token in the large language models. But the boundaries of these have actually all been handcrafted. And what I mean by that is that the handcrafting is the spaces we put between characters. Between words, I mean. But then there's a mechanical process called stemming, where if you've got a thing like walked, I walk down the street, that's 2 tokens. Walk is 1, and ed is the other. And the stemming's been done also by hand, where somebody's defined ed as the past tense of that word. So, you know, one of the things is to not be under any illusions about the extent to which this is just a machine. It's under every little bit of it in one way or another has been kind of handcrafted. But it's also multimodal, mediated by text. So the way in which image generators work, for example, is if I go back to this image here, the one that I made there, we've got all sorts of things labeled, which is robots and phones and saints and whatever out there in the world. So we've got this massive database of images, but they've got textual labels on them. And I only get the image by actually writing text back into it. So it's a multimodal process in which text is absolutely essential. So the image is only secondary to a textual technology. Oops, I'm going backwards, not forwards. So let me just talk about how this works now. I'm going to talk about how it deals with latent semantics. So here it is. This is something that I generated with Leonardo, actually, one of the image generators. I walk to work. Now, you know, the University of Illinois doesn't look like that, and I don't look like that. I don't have a bag like that. But when I said, put me in a modern city and da-da-da-da, and I'm thinking here about the just that token walk, okay? I walk to work. Now, the next sentence is, I walk the dog. Now, in fact, this is a very different kind of walking because, in fact, the dog's really walking me. It's straining on the leash, and I only did it. It's not direction. You know, I go around in a circle, I walk the dog, I bring it home again. Whereas when I walk to work, it's direction oriented. So in terms of, this is actually a different kind of walk, and grammatically it's a different type of walk, to be quite frank as well, which I'll get to in a second. The third example of walked is I walk the prisoners to their cells. So this is me in blue, and there are the prisoners, and I'm walking to their cells. Now, in fact, the way we deal with this in school grammars, we deal with it as walked as the past tense of walked, right? of walk. Walked is the past tense of walk. So we've got a subject and we've got an object, and we do a basic kind of parsing of that sentence. But in fact, if we do a much more subtle and more elaborate and more complex parsing of that sentence, it also involves transitivity, case, voice, mood. There's a whole lot of stuff going on there, which is a way for us to account for the different meanings of walk. Now, we account for that grammatically, and we actually have in the back of our minds practices of transitivity, case, voice, and mood. We might be unconscious of them, but our cognitive systems are grammatical in the way in which they process meaning. But the way in which a generative AI does is purely statistical, which is happens to find the relationship of this token walk to things around it, right, which might be prisons or dogs or walking down a wall or marching somebody somewhere against their will or whatever. So that what it will do, it will find the purely circumstantial relationship of that token with words around it and infer semantics, which are purely latent. So when I do semantics as a human being, it's not latent. It might be not fully conscious, but it's there. I'm doing it. But when I'm doing it, when the machine's doing it, it's doing it in a way where it's just guessing. It's not knowing that at all. It's just actually guessing at it from the words that surround it. So I've got a kind of difficult set of generalizations here as I finish this section of the talk. And that is that grammars are resources for meaning. This is quoting Michael Halliday, the great systemic functional linguist. And grammar is a theory of human experience. So in other words, all those things about cases and subjects and objects and nouns and verbs and whatever, and we get them more and more complicated about it. We have a working theory of human experience which is embodied in grammar, which are these, if you like, these are kind of semantic primitives which are embodied in grammar. Whereas all the generative AI does is just happens to have these billions of parameters without a grammar. They're just parameters which empirically kind of fit together. So that's a difficult kind of theoretical idea, but I wanted to try and give you a sense of the relationship of this technology to the human processes of making meaning. Chomsky has never been much used to educators, but ironically, this is now a useful thought about how we can produce an infinite number of new sentences because, not because we've got a big vocabulary, but because we've got this kind of elemental set of semantic structures. He doesn't think they're semantic structures, but I'm regarding them as that, which underlie the underlying language, a certain set of number of semantic primitives, which is how we figure the world, make sense of the world as human beings. These then are the differences, and this is my kind of summary slide on this here, which is generative AI is empirical and statistical, semantics is only latent, the relationships across vectors, and the limits of the limits of written text in the corpus. Whereas in human experience is theoretical and grammatical. But by theory, I mean something very, very similar. Simple, I'm sorry. For example, we have nouns, which are things in the world, and we have verbs, which are actions in the world, and we put them together. That's a theory. That's a theory of everyday, ordinary pedestrian experience. And this is kind of the functional classification of morphemes in a sense. And these meanings extend into embodied experience and they're immanent in the material world. They're not just simply isolated in the relationships that we find in text. That's, generative AI cannot go beyond the text. So these are some generalizations that we've got in here. We've been thinking about this question about a multimodal grammar, and there's an article referenced down there in the bottom of the corner, if you in the bottom of the screen. And we've got kind of a long playing version of this in the two books that Mary and I did, trying to build a kind of a theory of human meaning, which goes beyond school grammars and goes beyond text, where we ask these 5 basic questions of everything. What's coming soon is contextual AI. I'm going to talk that a little bit down a little bit further because contextual AI is very, very different. I mean, all generative AI does, it works on the historical corpus of human experience as reflected in text, that and nothing else. But what we have with contextual AI is a whole lot of information about us like these things here. And one of our arguments is that combining textual and generative AI could be very powerful. And in the last couple of slides, I'll talk about that. So, you know, this is our theory of grammar here. I can't go into this in a huge amount of detail, but in fact, what generative AI does is essentially deal with text in these areas. It doesn't deal with context, and it doesn't deal with much with sentiment as well. I will, well, I will mention the generative AI. I will mention this a little bit more. So we can use generative AI in education, both the foundation models, but also we can supplement those. I'm going to show you what we do in a moment with this technology called retrieval augmented generation. So we can actually bring discipline-related knowledge to a domain. So, for example, you know, the Peloponnesian Railway example. If I supplement the LLM with a book which is a definitive history of the Peloponnesian Railway, it won't make any of those mistakes. So we can do very, very well with the foundation model plus specialized knowledge that we've added to it, right? What we can do with contextual AI is we can actually then relate that to very specific places. And in fact, Apple Intelligence is going to do that now. The new Apple Intelligence, which they haven't launched yet. They've launched the hardware for it with the new iPhone, but they haven't launched the software yet. It's going to use OpenAI and then link it to all your photos, all your messages, all your geolocations, all your heart data, everything that's there, and build a kind of a more holistic view of what's going on. Now, you know, what's interesting is if we can do that in education, that would be really, really powerful. And in fact, right near the end, I'm going to show you an app that we're building where actually we'll be able to do that. We're actually a few weeks off having it ready. We've got it roughed out already. Okay, so that's theoretical. I hope it wasn't too overwhelming for you in terms of just wanting to give you a rough map of the terrain and help you kind of understand what the technology is and what it kind of does. If you didn't get all the details of it, we've published a bit of the stuff there. And we're still thinking through by the day, to be quite frank. This is so darn fluid. You know, I first did these slides a number of weeks ago, and I realize now that even some of this I slightly reframed because, you know, by the day this is moving and we're sort of getting still finding our feet with it. All right, case study. So what we have is we have this Scholar platform, people might know, which does a whole lot of things, 1 to 5 there. But what we've done as of the beginning of 23, which is nearly 2 years now, we've added generative AI to support learning. So this is this second part of the talk that I'm going to talk through now. The other thing we do is we data mine everything that happens, and we have a composite view of all learner activity. And this is our kind of, every learner has a kind of a detailed or a visualization of where they're up to. This is something where, you know, in these AI environments, we can be, for better and for worse, monitoring everything students do. And what we do is we classify into 3 macro areas. One is manifest knowledge. One is focus, which is the amount of effort or engagement that you've been involved in the learning. But we're very, very big on health, which is human interconnections, which these environments can do very, very powerfully if people are involved in peer interactions of one sort or another. And we're measuring everything that happens by these 20-something different measures here. So the circumference of the circle is what the instructor's expectations are for a course or a project or whatever they're doing. And each of the petals is how each of the activities is weighted. And you start with 0 and gradually you fill out the color till you get closer and closer to the instructor's expectations in terms of performance. Now, just to fill you in about where the AI fits in, what we have is that we have this environment where you start a project. And I'm going to show you one of these projects in a second, just briefly. So the project starts. And in this case, the project we're dealing with, our students are doing a project in the course that we teach. It's a master's and doctoral course where they do one major piece of work, 4,000 or 5,000 words, a major project. So they do a draft, and then they get an AI review, and then they revise and submit, and then they get peer reviews. What happens also at that point is we ask them to give feedback on those peer reviews to the people who gave them. We ask them to write a change note to tell us what they found the differences were between the human and the AI reviews, to reflect on that, and then to revise and submit. So that's kind of what's going on here. Now, this particular, and this is the underlying rubric we used. We could use any rubric, but we used the Learning by Design rubric. And one of the important points is this is kind of the top level criteria that we're measuring the work by. You're not meant to be able to read the other stuff. The only thing I really want to say is there's a lot of detail, a lot of granularity in what you're being measured by. Now then what happens is, this is an example of a work on the left here, where they happen to be writing about the advantages of peer feedback. It's one of our students in the course. And on the right here then are a series of AI reviews that come back to that particular student. So this is what happens on the screen. And the kind of learning model is that we have the kind of work you're doing on the left, which is in this multimodal text editor, where you write these extended projects, if you like. And then what's happening on the right is formative assessment, metacognition, and collaborative learning. So it's a kind of a dialectic between the left side of the screen and the right side of the screen. The left's the work, the right's the feedback, and this is the kind of things that are going on either side. That's the kind of pedagogical model that we're using here. Now here's an example of a piece of work. And I'm not going to go in and show it to you live because we don't have time for that now. I'm just going to share this one screenshot. And this is one of our students that's doing a work, 4, 5, 6,000 word work on the community mural as a multimodal experience. And on the right, it's one of 10 criteria. And what you can see is it's not like a normal rubric, which are normally terse with a lot of stuff expected behind a few words, expect you to understand a lot of stuff. With AI, you've got to be incredibly elaborate. So when we want experiential connections, we want to know about why the particular person comes to this study of the murals. So that's only one criterion on the right there. So if you go back to here, you'll see it's experiencing empirical activities here on the left. That's so you'll see just that. And in fact, there are 10 of these, and each of the rubric items is 100, 200 words. But what you've got to be with the AI, you've got to be incredibly explicit. Say it one way, say it another way, say it another way. Now, what happens is when they submit the work, it goes through the whole of their work, all 5,000 words, 10 times. It takes about 5-10 minutes to do it. And it goes through, and so we reconstruct each of the rubric items here as a prompt. So it's 10 prompts and 10 runs, 10 passes past the work. And here is just the beginning of the AI review. And you can see here, this has been written by the AI. And what we've told to do, this is just the experiential item. And I've got to say the feedback goes for, this feedback will go for 5 pages. There's a lot of feedback. And you can see here that it's really getting to what the issues are. And the EXP plus and minus is we have to tell it to be critical. It won't be critical unless you tell it to be that. And what's really interesting for us is this is really detailed and really relevant feedback. But one of the ways in which we do it is that we have built a retrieval augmented generation database where we put all our students' work for the last 5 years and everything that we as professors have written, which is about 35 million tokens, roughly 35 million words. It's a lot of stuff. And that's our database. So in fact, it's not AI that's measuring this and getting the feedback. It's the collective intelligence of our students who are all doctoral students and master's students, all incredibly smart, who know just as much stuff as we do in a whole lot of respects. It's collective intelligence which is giving feedback. So by the way, the retrieval augmented database, what it does, it takes the 35 million words that we put in and it vectorizes that. So the sources get entirely written over, lost, but it builds the relationship of words to each other in a way which is kind of about the subtle semantics I was talking about before. So this is the components of what we've got. We happen to connect to OpenAI's. We're now connected with GPT-4. Now this 4.0. But we could connect to any LLM. It's a kind of standalone piece of software that we've built. We've got this vector knowledge base, and we've got this prompt engineering. We run through it multiple times. And we're working on a whole lot of new stuff here. But for us, it's been a pretty incredible experience. And what I want to say is this feedback, all 5 pages of it, is better and more extensive feedback than I can do. I'm the professor. I've been doing this stuff for quite a long time, and I couldn't have done this well. It's got flaws with it. It's not perfect, but it's doing it in a way which is I couldn't put this much time into it. I do it when it was too late at the end of the course, as opposed to when you need it while you're writing. And there's no way I could write 5 pages of comments for every student. So what we've been doing is we've been comparing the human. So we do human as well as machine reviews. And in fact, we've got a number of research papers here that we've published. There are more on the way now, in fact, more published since then. And you can see here that in 2023, people kind of like the peer review a little bit more than the AI review. But the interesting thing is, and there are all sorts of advantages and disadvantages. What's interesting is that they see different things in the two. So at best, they're complementary. But and these are the sorts of things where people are talking about strengths and weaknesses of each type of feedback. Really interesting. There's kind of a lot of very subtle kind of differences here. But what's really interesting is we added the retrieval augmented generation at the beginning of 24. And we've now done it many more times than this. But since by the time this reporting happened, which was for spring 24, you can see now people are starting to find the AI review more helpful than the human review in terms of its quality, usefulness, and actionability. So that's a kind of a very, very an interesting set of findings. So, okay, concluding now about implications. What about AI in the future of learning? Artificial general intelligence. That's what they're all saying is going to happen. We're actually pretty cynical about this and pretty skeptical about it. We think it's got kind of quite defined and important uses, but it does replicate human intelligence. And the very idea of artificial intelligence we find problematic. So this is the man who coined the phrase, John McCarthy. And his definition of AI was making a machine behave in humans that we called intelligence if they were so behaving. And our argument is that they're actually fundamentally different ways of operating and ways of thinking. You know, we said before, human grammar is very different from a vector database. So 1955 is when he coined that phrase. We want to use, instead of artificial, the notion of cyber. And let me say where this comes from. It comes from the Kubernetes. This is actually the story on a Greek pot of Odysseus, who's there tied to the mast, being tempted by the sirens. And at the back of the boat is the oarsman, the Kubernetes. And what he does, the oarsman, is he keeps adjusting this way, then that way, this way, then that way. So it's a series of kind of feedback loops and adjustments. So that's where there was the kind of etymology of the word cyber. And what's interesting is we've actually had cybernetic mechanical systems for a long time. As I said to you before, I'm a bit of a historian, and this is Bolton and Watts steam engine, it's 1984. And see that little thing I've circled, that's given a wonderful name. I just love it. It's called the governor. So what the governor does is when there's too much steam coming into the machine, the two little balls, there is sort of like in a centrifugal relationship, they pull out, right? But when, and it slows the amount of steam going in. When it comes back down to a certain point, and there's not enough steam going to the machine, it puts more steam into the machine. So what happens is it's a way of automating the human process of controlling this machine, and it's called, technically, this is called a servo mechanism. So in a way, this is what we've just done with generative AI and with all this stuff is massively extend one of the key mechanical processes of, which we've had since the beginning of the Industrial Revolution. So what we have is we have these kind of relationships, techno relationships in the machine, but also social relationships that are connected with those. So what we want to do is we want to talk about machines that can learn. Yes, these machines have trained themselves about the relationship between words. We haven't trained them. We do modify them and we adjust them and we've set up the training for them. But yes, there's a lot of machine learning in there. And we have social, which is human learning. And we have these things able to relate to each other. And we say cyber-social intelligence is a learning relationship. That's our definition of something. We'd rather use this phrase than artificial intelligence. And look, one of the really important things is that human-machine intelligence, I've said this a few times, I'll say it again, are so different to even use the same word, intelligence, is a kind of a travesty, because brains are much more than kind of zeros and ones. Bodies feel a whole lot of things, and they're much more than brains, but also there's meaning in contexts around us, which we leverage, which the AI can't get to directly except via this other stuff. So this is our definition of where we're going with cyber-social literacy learning. These are kind of a little agenda. We have a paper on this, which you're welcome to read. I won't go into any great detail now. But what I want to talk to you in the last slide, and this is actually the last slide, yes, is what we're working on now. So, and actually I've seen the mock-ups of this today, and we're hoping to have it working in a few weeks, is that what we have is we have a students doing the work with the support of AI inside the editor, right? So in other words, as they write, they can have the AI helping them. But then we have a cyber-social learning log where we can say, look, the percentage of, we want you to do at least half the work. Yes, the AI is going to help you. Of course, it's going to help all of us in the future. But if you're writing this project and you're using AI to help you in all sorts of ways, to give you ideas, to help you format things, to help you brainstorm, to proof the work at the end, to check that it's, there are no errors in it. But we want you to have done a certain percentage of the work, maybe half the work. So what we're going to do, and this is the contextual AI part, to be quite frank, if we capture keystrokes and we capture timestamps and we capture click streams and all that kind of stuff, we'll be able to estimate how much of the work is yours and how much is the machine's. And if it's the machine did the whole damn thing because you just told it to write the essay for you, we can see that. So it's the answer, it's the solution to that problem about how you, how you deal with what's colloquially called cheating. So that's a big journey. I hope that wasn't too much for you folks. If you want to know more, there's a QR code there where you can see recent things that we've published, articles that we've published, and we're thinking this through on the fly. And there are some other social media links there where you can join in the conversation. So yes, that's my story. So folks, what do you think?
Thank you so much, Professor Cope. It was amazing. I think that people now can go for a Q&A, so please feel free to write your questions and comment in the chat. If you prefer, you can write in Portuguese or Spanish. Me and Victor will be happy to pass them along to Professor Cope. But for now, I would like you, if you could, you mentioned early that to the model give really a critical feedback. You told us that we needed to go around, and if I am not mistaken, a way to go around it's RAG, right? It's to contextualize the model. Is that so? Do you suggest another, I don't know, prompting design or prompting engineering as a way to go around? What do you suggest besides RAG?
Yep.
And could you explain for our listeners listeners what is RAG means as well?
Okay, so firstly, these things have been tuned not to be critical because a chatbot has to keep you engaged and has to be friendly and all that kind of stuff. They've been made that way by the humans that have fine-tuned them. So the way to get something critical out of it is to actually, there's this notion that's developing in this technology called agents, right? So is to construct an agent in there, which is designed to be critical, which is, okay, I'm a sympathetic critic. I'm a sympathetic critic who is charged with being constructive but critical of this, who kind of doesn't agree with you in some quite fundamental kinds of ways, but nevertheless wants to help you and wants to give you advice. So the interesting thing is all this is programming language with language, right? So what you do is to get around the fact that it's overwhelmingly positive. You find ways to get it to be critical while not being destructive. You give it quite explicit instructions about what to do. Now, this is called agents, and one of the interesting things is getting looking at things from multiple perspectives. So, and giving the machine ways to tackle something from multiple perspectives and giving you multiple perspectives on things. The RAG database thing, to answer that part of the question, is this. The foundation model is, which is what ChatGPT provides you, and what or whichever one you use. One of the other ones, Anthropic, or whichever one you use, is basically everything they've found on the web, which is Reddit and Wikipedia and everything they can scrape from the web. So it's as much text as they can possibly find from any possible source anywhere, billions of words. And what they've done is they've taken billions of words and multiplied by billions of words, which is they've worked out the relationship of every word to every other word. Right? Now that's computationally sort of almost impossible, but they've found ways to rationalize that via this transformer architecture. Now, what you can do then is that is everything in the world. If I'm in a specific domain, what I can do is I can do the same thing, which is I can vectorize the words, which is build this physical relationship to each other by putting the words into a thing called a vector database, and which then builds specialized knowledge, and that gets prioritized in the analysis. So in our case, we did, our students write about technology and learning, they write about pedagogy, they write about every conceivable aspect of learning that you can think about. So what we do is we then do the same thing with that, is we build a vector database. So we have 35 million tokens where we've got the relationship of every token to every other token worked out. And that then becomes the resource which produces a domain-specific response for the students. Now, if I was doing astrophysics, I might put in digital copies of 10 astrophysics textbooks to do it. It's in other words, what it does, and it produces much better targeted responses to the particular domain. So the environment we're building now is going to be one where the teacher can upload, I'm going to call it a knowledge base. They can upload a knowledge base. The knowledge base becomes a resource for the learning, right? And that could be any topic, any subject you want to name.
All right. And I was wondering if this technique is only about text per se, or it can also be, is there a kind of RAG that to work with image and video as well, or it's for now
Right.
it's just text?
Okay. You get images too, but what you got to know is when you put an image, it's going to analyze the image and give it textual labels. This is only a textual technology, right? So yes, it'll do images and probably do them very nicely. So let's say you've got, a 100 pictures of buildings because you're in an architecture course. You put 100 pictures of buildings in, but it's not going to be analysing the pictures. It's going to be analysing the labels that the machine gives to those images, and then the response is going to be you're going to write something in to ask it a question, and then it will take all those labels and use them. So the thing is, it is only, as I say, at the risk of being boring, it's only a textual technology. Now, having said that, the image generating stuff is spectacular. You've seen, I used 4 or 5 generated images in this talk, and it's pretty darn amazing. But it's a multimodal technology. The word we use in our grammar is transposition. So what it does, it mechanically only works via transposition through text.
Nice. And how teachers could, because the way I understand RAG, it's not like a common technique, or it's not easy to do, I suppose. How teachers could go around.
Right. Yep. So what we're going to do is the software we've got today, that, as I say, I was working on it today, and we're going to hopefully have it launched within about 2 weeks, just for our own internal testing, is that the teacher will be able to build, we're going to call it a knowledge base. So the teacher, if they're teaching the French Revolution, they'll put in a pile of stuff about the French Revolution, and that's the knowledge base, right? So, and then the chatbot will, they might put in 4 or 5 books about the French Revolution. They might link to the Wikipedia page on the French Revolution. They might link to websites they think are reliable and good on the French Revolution. So they put all that, the teacher will put all that stuff in, and it will then vectorize that stuff they put in, right? So that's what we're building this notion of a project. So the students are involved in, a project, just, it's not literally a project, it's just an activity. Even if they're writing something short, like 100 words or 200 words, or doing something small, we can build this knowledge base. So we're building out a mechanism for where teachers can easily use RAG technology.
Okay. Oh, so I will read a question that was about from Ana Paula Coelho. She was asking if you could give more example how to use generative AI, how teachers could use generative AI and their classes outside this CG Scholar, if that an example that they could use, like using for analyzing students' text or so.
Right. There are 1,000 ways you can use it, and it's eminently usable. The only thing is that the better ones are not free. These are private companies that are making money. So, there are books that are coming out now about how to use it. I mean, in a way, we're not hugely interested in how you use it. We say in the wild, which is just sort of the open public interface. You can get the students to use it to build a plan. You can get the students to use it to, you have to use it, do their project for them if you want to. That's the trouble, is you can't know how they've used it. They might do the whole project for them. You can get it to proofread things. You can get it to all of that stuff. The trouble is it's uncontrollable, and you won't know how much the AI has done and how much the student's done if they're just using the publicly accessible interface. What we're going to do in our space is that if you've copied and pasted something in, we're going to assume that it's plagiarized, because we're going to assume we're going to be watching your keystrokes, watching your, so we'll know what the work you've done by keystroke capture. That's the textual AI part. There are great, using the public ones is really fraught on a lot of fronts, because it's A, not domain specific, B, you can't know how much work the student did and the teacher did, the AI did. But there are all sorts of ways you can use it, and there are books about how to use it now. People are madly publishing stuff about how to use it, but it's really fraught. So we're not kind of that interested in how to use the publicly accessible stuff. We're interested in how we use it in educationally helpful ways. Right, that's what we're really focused on. So, which is fine-tune the domains by the and also where we're able to know exactly what the student did, how much work, how much time they spent on it, how many keystrokes, whether they copy or paste. So, yeah.
And by the way, is CG Scholar open for Brazilian teachers to use, and also how they can use?
It will be open. So it's currently open for non-AI uses. You can use the community space without paying anything for it. It's all there. The AI stuff is all being pretty experimental, and we haven't opened it up to the public yet. One thing we will do pretty soon, if people are academics and researchers and you want to trial it and write it up as research, we're very interested in that, because we're interested in learning from that systematic experience, as opposed to sending it out to the whole wide world to use. So if there are any folks there online who are interested in doing this for their master's degree, or as a dissertation or as a project that is part of their studies, any professors interested in using it, I hope by early next year we'll have something that other people can use. Our bigger dilemma, by the way, is that we have to pay for our back-end access to OpenAI. So to give you an example, the review you saw before is incredibly expensive. 10 prompts on a big piece of work, and we run past it 10 times. We've got our RAG database. Each review costs about $1. Right? Now, one way to think about that, it's the major review for a whole course in a master's degree or a doctoral program, or the major project. So $1 is not much. It's less than half a cup of coffee or something, but still it's $1. So that's what we have to pay OpenAI, because it's really intensive use. It takes 10 minutes. We're for every work we're talking to the OpenAI machines for 10 minutes. Now, in fairness to OpenAI, by the way, that uses an incredible amount of electricity. There's a lot of stuff going on there. People think this is just, this is heavy industrial infrastructure. This is not ephemeral, immaterial, nothing. This is a lot of electricity, and that's very problematic, by the way. It's the end of the world in terms of climate change. So, so when we put this in place, realistically, we're going to have to charge for it as well, because we're paying for the foundation models, and we have services we have to pay for. So this can never be a free service, I'm afraid. So that's just one of the realities of this. And the OpenAI people, you can rest assured, they'll only be letting you in for free because they're about to take your money. That's just what the world is. If we lived in a world where the university or our schools could pay for the infrastructure, but they're not going to do it. If we lived in an ideal world, a government of the people would regard this as a citizen's right to have access to human knowledge in an ideal world, and it's a public information system, and it would be paid for by the people, so to speak. We don't live in an so we're going to have to pay for this, and I'm afraid our users are going to have to pay as well. But in a research context, we're happy to pay ourselves. We get grants and we earn money for various things, so it's a struggle. But if folks are interested to experiment with this and try it out, we're hoping to have a version of it which will. Our first implementation as new environment will be within a couple of weeks, but but probably early next year we can do that for researchers. people like you, Eduardo, and people who
Yeah. No, for sure.
can't see.
I'm really impressed by the tool, by what Dwayne are doing. Right, he's amazing. The guy
No,
that
it's amazing.
is
Look,
one
and
of
look,
the
we have.
most incredible uh, guy I have met with. He's amazing. The way he understands AI, the way he can he's fine tuning all that. It's amazing. Oh, the whole group. It's so
Yeah,
I'm excited.
we yeah, we're doing well. We're very lucky to have a very good group, and we've just got a new professor, full professor in our program, Liam McGee, who's just incredible understanding of this stuff as well.
Yeah.
So, So
So
we're lucky.
so another question. I don't know if you have time, Professor. Is that okay?
Yeah,
Just for another
yeah,
question.
yep.
So talking about environment and people, government. So what are your perspective on the ethical implications of generative AI, particularly regarding of authorship and intellectual property?
Okay.
Um,
So the intellectual property issue is a tricky one. So obviously, what people have to do in intellectual work is know and acknowledge sources, right? So in other words, you can't use the AI for sourcing. You've got to be searching things, and you've got to be properly referencing things. You can use it for a whole lot of intellectual activities, but not for sourcing fact and not for stuff has to be referenced, and that's a separate intellectual activity. And one of the things that we have to do now, one of the things is that AI, it's not the machine, it's actually collective human intelligence, right? That's the really important thing. Marx had this wonderful notion in the introduction to the Grundrisse of the general intellect. It's the general intellect. So, when I walk into our library at the University of Illinois, it's full of books, and in there is this incredible legacy of the human intellect upon which I draw, some of which I just absorb it, some of which I cite it. So we have to regard this as another extension of the general intellect. So, but then we've got to make sure that we're also going back to sources, citing those sources, using those sources effectively. Now, one thing we can do with the generative AI, and this is another whole story, is I can put in 200 journal articles into a RAG database and ask AI to synthesize those and cite from them, and it will. So in other words, it's also a technology for doing synthesis across huge amounts of text. Now, we used to do that ourselves as human beings with research assistants and teams of people and speed reading and card catalogs and whatever. This kind of then supercharges, in fact, those historical processes. But like the library, it's not a machine, it's the general intellect. Now, the real problem is when the library was built, they bought the books. These people have stolen the books. That's a serious problem. Publishers are fighting with them now about getting some recompense to authors for what they've done. So that's a fight that's still to be fought.
yeah. So another question, I think in the same regard. Which are the implication of the so-called cyber social society to education in emerging countries like ours, Brazil, considering inequalities in access and resources?
Yeah, the answer is yes, there is that. But the difference between this and other technologies is that it's scalable and it's relatively cheap as well. So, yes, inequality is a problem anyhow that we have to deal with. and we have to deal with it in structural ways, and we have to deal with it in terms of redistribution of social resources. That's a struggle all of its own that has to be done. The only thing we can say about these technologies is to bring the whole of human intellect to bear in a dialogue with a student. This achievement is pretty impressive, to be quite frank. I think it has the potential to reduce educational inequality by making high quality teaching and learning experiences and available to many more people, including poor people. Unfortunately, it will be at a price, but let's hope it's a low enough price for it to be accessible. Again, for me, in an ideal world, it would be public responsibility to provide this at no cost. We don't live in that ideal world. That's what I would say. I mean, I'm not, if I were to say it now, that's not realistic. I would say nationalize OpenAI and make it a public utility. Well, that's not going to happen. But that's, and given that's not going to happen, what our responsibility is to find the least expensive way to make it accessible in high quality forms to the most people.
Yeah. And last question. So would you say that we have to learn, this is from Carolina Paulino. Would you say that we have to learn and teach how to use generative AI, but also how to feed the model as well? So we have to learn how to use, how to cheat, and how to fine tune, or how to do those RAG kind of techniques.
Look,
As
the truth
teachers.
about it, yes, but it's not that hard. We're trying to build something which is relatively simple, where we say to the teacher, okay, what do you want to teach? What do you want the kids to be learning? Upload this pile of stuff into this here, and it will go into. We don't even say it's a database. We're just going to call it a knowledge bank. Put it in the knowledge bank. Or put it in the knowledge base. Put your stuff here, and then what's the prompt? What do you want the students to do? So what we're hoping to do, what are the measures of success? Give us a rubric. So what we're hoping to do is make that relatively accessible to teachers, so they don't have to worry about all the technology. So that's what we're working on at the moment.
Okay. As we come to the end of the session, I would like to once again thank you so much, Professor Bill Cope. It was amazing, inspiring, and enlightening experience, and I deeply appreciate your time. Thank you so much. It was amazing, and I hope that one day we could have this conversation again. And with Mary, send my regards to Mary.
All right. Okay, everybody. Well, very nice to spend the time with you, and see you all.
Bye.
Bye. Bye. Bye.
Vitor? Pessoal, obrigado. Obrigado pelas perguntas. Espero que tenha sido uma apresentação proveitosa, como foi para mim. E muito obrigado pelas questões, pelo engajamento de vocês. Obrigado, Vitor. Obrigado, Vitor, também. Obrigado aos Vitors. E até uma próxima. Acho que continua aqui, para fechar aqui. Terminou o evento. Tá joia. Obrigado, Vitor. Fechou? Não?